Good afternoon, evening, or morning on this glorious day that ends with day. Wherever you're at, welcome back. Your friendly professor of math, trigonometry, Alan here. We're going to start in with this new topic called radians, which is very, very important for us moving forward. So let's get to it. As I mentioned, very important section moving forward because what we're going to be talking about is still all the stuff that we've been going over thus far with all of our trig functions, how they come out as far as their values, but also when dealing with this, talking about this new way to measure angles with real numbers rather than our degree measurement that we've only dealt with thus far. So again, very useful, has a ton of different types of applications, not only in engineering, but also a lot of the sciences. Okay. Where it is a little bit difficult is because we're not as familiar or obviously comfortable with radian measurement. So it's going to take some getting used to and a little bit deeper understanding. So we're going to start by defining and then deriving what actually a radian is. And just based off of the name, you may have an idea, but here is both the definition and a graph representation of what a radian is. Now you may wonder why they called it a radian, and it may sound familiar as well. But obviously it is called a radian because it resembles the name radius. And so what we're going to define a radian as, it's pretty simple, but we're going to take a circle centered at the origin, and we're going to go ahead and draw some length, any length, we'll call it a radius. By definition, when you go from the center out to any point on your circle, that is a radius. However, when we go and take that to build something a little bit differently, so if I was to go from that point and I was to extend it out in our x-axis, and then if I was to take that, I was going to take that which we called an initial length, and I took it and rotated it. And not just any old distance, not any old angle, but specifically I took it and I rotated it a length of also r. So then this curved part, which on a circle we call the arc, that also would be the same length as this radius here. And since this is the same length, and from the center out to any point on our circle is also a radius, this is where it gets the name a radian. So by definition, we're going to call this angle here theta that is formed by two radii, that's plural for radiuses, but the arc length that those two radii intercept is also going to have the same length as these two things. We will call that by definition 1 radian. All right, so we're going to call theta that 1 radian. And so there's the definition for you. Now I'd like to derive it. So let's take a look at what would happen if we were to actually go all the way around the circle rather than just that length of r. And if we're going all the way around a circle, hopefully you remember the name of that is called the circumference, which is basically the perimeter, but of a circle, since the perimeter, you have to add up all the sides and a circle has no sides. We call it the circumference. And if you remember from geometry, the formula for circumference is 2 times pi times r. So how many degrees would the angle be in order for us to go all the way around our circle? We know that by definition is 360 degrees. And we said what we called that length to go all the way around a circle is called the circumference, and this is the formula for that. So then this new form of measuring an angle we call a radian, we want to know how many radians would it take to make one full circle as well. So we already know that it's 360 degrees to go all the way around in degree measurement of an angle, but our question is, what would it take to go all the way around in radian measurements for our angle? So let's check that out. Let's go ahead and take a look at this circle here and try to figure out what that might be. So we know for now that if we were to start from our center and go to the x-axis, and we were to take that value and rotate it all the way around, that angle measurement, we already know, theta we call it, would be 360 degrees. But our question is, what would it be to go all the way around in these new things, which we'll abbreviate just the first three letters, just like all of our trig functions, with RAD. Yeah, it's pretty cool. It's rad. So what we're going to do is we're going to try to figure out what it might be using our circumference, which we said is 2 times pi times r. Because we already know if this was a length of r, then we could measure that same length here and call it r, and then connect that endpoint to get another length of r, and that would be our angle in radians. So how many of those do you think we would be able to make to go all the way around? And so if I just copied this a little bit here, you can now see that if I kind of map this out, now again, this is by freehand, so you can see some are a little bit larger than the other. They should all be the same length. There's about 1, 2, 3, 4, 5, 6, it looks like, radians to get all the way around. About. Notice there's a little gap here. It's not quite 6. It looks like it's a little bit more than 6. So how do we figure it out exactly without having to get a piece of string and measure that radius length and again and again and again all the way around to figure out exactly what it is? And what if it does come out nice and neat? And that'd be great if it's a nice whole number, but you know how the real world is. It doesn't work out perfectly. That's why we have a symbol like pi. So what we're going to do is actually use what we already know. And that's the fact that in degree measurement, we know it's 360 degrees. And to get all the way around on the outside using radii, what would be the best radius to actually choose to find that circumference? Well, what would make that equation on the right side be really nice? Any one of you hopefully can come up with it. And hopefully you figured out my little hint there. It would be 1. So if we made all of these radiuses, these radii, a length of 1, then we would know that the circumference would be equivalent to 2 pi times 1, or 2 pi. So we know the exterior all the way around would add up to be those radius lengths of being 1 a bunch of times, and therefore to get all the way around it would be 2 pi. Therefore, we can say that since this is a way to get all the way around, and this is a way to get all the way around, that therefore those two things would have to be equivalent. And that's the quick, easy proof of why radian measurement to get all the way around a circle is actually equal to 2 pi. Now you may be wondering, well, 2 pi, you said there's about 6 of them. 1, 2, 3, 4, 5, 6. Well, remember I said that there's a little bit of a gap. So one thing you may remember from geometry or early on in your math career is what you defined pi as. And most of you know pi as the approximation 3.14159265535. Goes on forever, never ends, never repeats. And so we usually just use 3 significant figures. And so if I took that and I plugged it in right here, I know that this would be 2 times that 3.14-ish, which would give me approximately 6.28. So now you can actually see that this little gap there would be 0.28 of a radian measurement. So to get around an entire circle, we're going to say that it's equal to 2 pi radians. So not too bad. To be able to memorize that, you're just going to have to remember to get all the way around a circle. One thing you already know is it takes 360 degrees to go around. Well, now we need to memorize that it takes, in radian measurements, 2 pi. And what would be even easier than memorizing all the way around 360 or all the way around 2 pi? Well, remember, if we know that these are equivalent, then we can do whatever we want to an equation. And if we want to make that look a little bit better by dividing both sides by 2, cutting it in half, in other words, then we know that instead of going around 360 degrees, we can go just half of that, which you already know half of 360 is 180, and half of 2 pi obviously would therefore be pi. So here is the new trig form of pi that I want you guys to memorize. And that is that pi is equal to 180 degrees. Right? Not just the 3.14 that we've always known throughout our math careers and used. You're now going to have to memorize that pi is equal to 180 degrees as well. All right? So let's keep talking about this, and then we'll start using it here in just a second. So there's that format that I just explained to you, where if we let our r equal 1, then we know that this angle theta all the way around for our circumference is equivalent to 2 pi radians. All right? So the cool thing is, when we're talking about these, is because we've talked about what S is, our arc length, and circumference, and radius, we then therefore know that if we were to take the r radius and the s arc length, those are both measurements in terms of inches, feet, yards, whatever it might be, meters, centimeters. So they call that a pure number. Because when we take the s and divide it by the r, since that is a length and that is some length, then whatever they are, say they're centimeters, then we're going to be able to cancel those out, which means there is no unit measurement. So that's pretty weird, because when we are labeling angles, we've always written it as 180 or whatever the measurement might be degrees. And we've used that symbol up there to denote an angle measurement. Well, now when we're dealing with radians, what did we just get done saying that 180 degrees is equivalent to in radian measurement? A little bit more than 3 pi. When we cut that up there, we had 1, 2, 3, and then a little bit more right there to get to that 180 degrees. So it's not an exact number. Unfortunately, it turned out to be the number pi. So for us, that means we need to know that this symbol can mean 2 things to us. A number, they call it a pure number, like 3-ish, 3.14, or it can also mean to us now 180 degrees. And we didn't know that that is exactly what it's equal to in angle measurement. Notice the equal sign, where if it's that 3.14-ish, notice I keep saying ish. And I know you might be wanting to get that ish out of there, but in order to do that, you'd have to use this symbol. It's equivalent. It's exactly 180 degrees. But as far as the number goes, it's approximately 3.14159, and it continues on. So you need to know the difference between those two and pay very close attention to them, because we will be unfortunately using both of these, that and that, just depending on what we're trying to find. In approximate, we'll use the 3.14 with that number. If you want an exact angle, then we'll either substitute in what we know pi is equal to, 180 degrees, or the cool thing is we'll just leave it as pi without actually taking and doing the approximate. Okay? So radians are a little bit weird in the fact that there's not a unit measurement. Okay? When we do this, you will not see anything with it. It will just be that as the angle itself. So again, it's going to take some getting used to, but hang in there. It's not that bad. The cool thing is, because we're adding in this new measurement, we're still going to go and review all of the stuff that we've talked about in the first two chapters. And that's all of the trig function values, Pythagorean theorem, all that stuff, reference angles that I harped on. It's just going to look a little bit different. Okay? Hopefully none of you guys are on the diet recently, because we're going to be talking a lot about pi. So we can use that relationship that we just discussed with 180 degrees being what is equal to pi as an angle in radians in order to go from one to the other. Now remember, I told you one of the most important things in all of math is being able to multiply by 1. So if you wanted to take this right here and figure out what 1 radian is, all you got to do is take that pi radians, which we know is equal to 180 degrees. And again, because it's an equation, we can do whatever we want. And if we want to know what 1 radian is equivalent to, then we will just divide to both sides to keep it equal by what in order to make that left side become a 1. Very good. Pi. Because I know anything divided by itself is a 1, and now we know what 1 radian is equivalent to. It's equivalent to 180 degrees over pi. Now, if you want to know what that is approximately, all you got to do is approximate what pi is. So you would literally just substitute in what pi is equivalent to approximately, which is at 3.14. And when you work that out, then you will get what 1 radian is approximately, and it actually comes out to 57 point something degrees. But because it's an approximate, we're going to use something much easier. We're going to try and do this in our head. So rather than using pi as 3.14, we're just going to say it's 3-ish. And if we took 3-ish and divided it into 180, we say then that 1 radian is approximately, how many times is 3 going to 180? About 60. Even though if you punched this into your calculator, that 3.14, you would have gotten about 57 point something. We're just going to round it because we're using 3 so that we can do it in our head in place of that pi. Okay? So that's what all of this is saying here. And we can go the other direction for 1 radian, or we can say what 1 degree is. It's also equal to pi over 180, doing something very similar. Just taking that same statement that I told you to memorize and then dividing both sides by 180. That would then get our 1 degree on this side, and it would be equal to pi over 180 degrees on that side. So that, my friends, is what 1 degree is equivalent to and what 1 radian is equivalent to. So notice it's the same, just the reciprocal for that ratio. So that thing that we're going to be multiplying by is just a fancy looking 1, and that will allow us to then convert from one to the other. So like I mentioned, if they ever say to give them an answer exactly, they want the exact answer, then you can just leave it as pi. Right? But if they want an approximate answer, then they want the decimal approximate of what pi is, which we said is about 3.14. So then that's what we'd have to use to approximate. We'll use the approximate value for pi. And if they want it exact, we will leave it exactly like it is. Pretty simple. That's kind of nice actually when it's telling us to leave it in terms of pi, because then there's not much to do. So a couple of things that you got to be careful of is when they put this symbol, you all know what this means because we're familiar with that symbol. It means degrees. And we know, hopefully, that that angle is about right there in quadrant 1. But if they were to just put an angle of 30 and they don't put that up there, which is why it's important for you to put the degrees, that means radians. And if it's 30 radians, remember we said it takes about 6 to go around once. So we'd actually be going around about 5 times. So be very careful when writing things down. These little symbols, paying attention to details, really, really important in mathematics. So one more time, let's talk about that thing that I told you to memorize. Trying to hit this point home. 180 degrees, we know, is half of a circle. What would that be in radians? It's exactly pi, or approximately 3.14 radians. So here are all the reference angles on the left over here that we've talked about in depth, including the 0 and all of the other quadrantal angles of 90. So since these are all multiples of 90, we want to see, well, this is the one that I told you to memorize. 180 degrees is equal to pi, or 3.14-ish. Well, then what would they all be if they're all multiples of 90? Well, in this case, we would want to then know what 90 is. So since we know 180 degrees is equal to what? Pi radians. Well, then how would I get it to 90? Just cut it in half. And I know this is 90, and therefore this is exactly pi over 2. And all you need to do in every single one of these quadrantal angles then is multiply it by that multiple of 90. So if I had 2 90s, I know I'd have 180. If I had 3 90s, 270. 4 times 90, 360. So if you notice, that's exactly what we have here. We have 1 pi over 2. Then this would have been 2 pi over 2s. But those cancel out, so we just give them the simplified version of pi. And then this is 3 pi over 2s. And then this one we could have written as 4 pi over 2, but again, that simplifies to just be 2 pi, like this one is just pi. So those are very simple. We're going to use those a lot in the next chapter, so make sure that you guys pay attention to 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. That is our quadrantal angles for now radian measurements. But we also need, very, very important, all of our reference angles. And we'll just talk about quadrant 1 and then we'll get into all the others. But our reference angles, starting with the 30, and that 30-degree angle, again, we could just take the one that we do know, which is 180 equals pi, and we can divide that to get a 30-degree measurement. And in order to do that, we would have to take and divide this by 6. And I'm just focusing on the 18 there. So if I take 6 and divide it in 18, I know that's a 3, and then I'll have to tack on the 0. So that's why I chose 6. So then that would give me 30 degrees here equals pi over 6 there. All right, and we can do that for every single one of these. So I'm not going to take the time to do that, but 30 is pi over 6, which if you had to approximate it, what does that mean to approximate? You would use the 3.14 and divide by 6 to get what this is about. Okay, we don't use these that much. You have to memorize these things, which are now our reference angles in radian measurement. Right? So 45 is pi over 4, and 60 is pi over 3. And again, all I see is that this pi up here is equivalent to 180. And so if I divide that by 3, I know that 3 goes into that 18, 6, and then 0, 60. Pi over 4, a little bit harder, but 45, so that's easy for the 4. And remember, 30 and 60 are complementary, so 3 and 6 are complementary to those. Okay, the 3 and the 6 and the 3. Whatever you do, make sure you memorize these because, of course, we're not going to just play in quadrant 1 for the 30, the 45, and the 60. We're also going to do that in quadrant 2 for the 30, the 45, and the 60. Quadrant 3 and quadrant 4. So how can we convert these things? Well, like I mentioned, you can just take what you know, and that is what pi is equivalent to. 180 degrees. So if they give you something like 9 pi over 4 and you have no idea where that's at, here's the beautiful thing about radian measurement. It already tells you what your reference angle is. It doesn't really matter where you're at until you're trying to find your sine. I know I'm dealing with a 45-degree angle, and I'm going to be doing it 9 times. So if I just wanted to actually build this out, I know 45, 1, 2, 3, 4, 5, 6, 7, 8, 9 times would put me right there. That's actually equivalent to a 45-degree angle. We call those coterminal angles. Or you can say that this pi is equal to 180 degrees. Simplify this whole fraction, multiply it out, and get 405, which again, if we subtract that extra full circle, we know that we'd be getting 5, and then 40 minus 36 is 4. There's our 45-degree reference angle that is coterminal to that 405. Okay. The other way, hopefully you can see that, is remember 2 pi. If I have 9 pi over 4, I can multiply this by any one that I want. And since my denominator is already a 4 here, then I'm going to multiply by a fancy one of 4 over 4. So that would give me then 8 pi over 4. And remember, that's what 2 pi is equivalent to. So if I just subtract off 8 pi over 4s, one full circle all the way around that I didn't need to do, then I know I'm left with just 1 pi over 4, which is what we said we would have. Okay, so a bunch of different things that we're going to do with these. We'll just start off with converting, and then we'll, at the end of this section, figure out how to evaluate our trig functions in this new angle measurement of radians. So before we do that, I wanted to show you that unit circle again, going and rotating all the way around, and you can see that we have our 30 degree, which is a pi over 6, and then we have our 30 degree over here, which would be 5 pi over 6. Another 30 degree angle, 7 pi over 6s, and then another one here of 11 pi over 6. And we can continue on this with all the other reference angles. The 45 is a pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then the 60, pi over 3, 2 pi over 3, this one here in quadrant 3 and in quadrant 4. And then you can see hopefully which ones are left. Those are my quadrantal angles. 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, and if we went all the way around, 4 pi over 2 or 2 pi. Okay, so these are the things that I want to make sure that you guys start seeing. Hopefully you'll start memorizing them because like I mentioned before, these are still our reference angles, just in a different type of measurement, which if you don't like, not a big deal, as long as you know how to convert it and convert it quickly to degrees.